Good day, everyone. My name is Tim Fiola, first-time presenter here at Networking Field Day. I'm excited to be here, so thank you for your time. Today, we're going to be talking about managing circuit maintenances using Nautobot's circuit maintenance solution. Okay, this is the agenda we'll be following real quickly. We'll talk about why we need this solution, what it is and what it does, and then we will close out with a demo of the solution. All right, let's just talk about the problem real quick here. Every network is built upon circuits, and every circuit has periodic maintenances during its life cycle. And if a maintenance is not properly handled, it can at a minimum impact your operations. It can also start to have an impact on your business as well if they're not handled properly. Handling the circuit maintenance manually is also time-consuming, prone to errors, and it just doesn't scale. And why doesn't it scale? Well, someone from the network team, when you receive a maintenance, someone from the network team has to read and understand the maintenance, which often involves parsing text, CSV files, HTML files, what have you. Then from that, they have to determine which circuits are affected and when, and then they have to plan for the maintenance in their systems. Say you do that, but then you get an update on the same maintenance a week later, you have to restart that entire process. So a single circuit can cause hours of maintenance-related work per year for network engineers. And for a company with many circuits, this can be a huge administrative burden, not to mention a real morale crusher for the highly skilled network engineer that's called upon to do this kind of data parsing work. So we've discussed the manual approach, the kind of the legacy approach to this. Let's see what we can do with the circuit maintenance solution. So under this approach, the network service provider, the NSP, sends a notification. Then the circuit maintenance solution is an application running on the Nautobot platform that dynamically fetches, parses, and stores the circuit maintenance notification and creates an easy to read and easy to deal with object in Nautobot for that maintenance. And we will show this in the demo as well. Now, once you have that information in the source of truth, it's very easy, since the source of truth lies at the center of your automation infrastructure, it's very easy for the network automation infrastructure to then grab that information from a single well-understood interface that Nautobot provides, and then do other follow-on activities like proactively updating the configurations, sending reminders, or silencing alarms. So this solution is a single integrated application for the Nautobot platform, and it's already in use within multiple enterprise customers right now. So this is ready to go, ready to add value. So what does this solution actually do? It does a few things. One, it retrieves the maintenance notification from the network service provider. There's two ways to do that. One is available today, and that is dynamically reading emails in an inbox, parsing the emails, and then, reading the emails and then parsing them automatically. Coming soon, if your NSP, your service provider, allows you to access their maintenance schedule via APIs, this application will support that. That is coming very soon to the application. The second thing it does is it then parses the notification, and we'll talk a little bit more about that in a few slides here. And then it organizes the maintenance in Nautobot in the source of truth. This includes creating a maintenance object, relating the maintenance object to the related circuits, and back again from the circuits to the related object. And then it also assigns the received impact for the circuit to the circuit in Nautobot. And we will, again, cover all that in the demo. This is a quick overview of the solution architecture. So at the main part here is Nautobot. And Nautobot adds a couple core Nautobot models, including the provider and circuit data models. Now, in addition, the circuit maintenance application, like John mentioned in a prior session, the application can add additional models. And in this example, it includes the notification model and the circuit maintenance model. Okay. And then up top there in the red, you see the circuit maintenance parser. That is a huge part of this. And that, again, just goes out and actually parses the maintenance. And we'll talk a bit more about that now.
So I've got a question for you, and I hope I'm not skipping ahead to your demo. This is Kevin Myers. I think the circuit maintenance is a really, really interesting piece. And the question I would have is, if you are running a large enterprise and you're dealing with all those circuits, and your carrier that you use for DII or MPLS decides to change their format in email, how do you handle that in an automated way? Like I could see like taking an existing structured format and building automation around it, but how do you handle changes?
So that actually is the third point here on the slide, but let's talk about that first since you asked. Sure. The Parser Library supports formats used by 21 of the major network service providers right now. Already there's a lot of functionality built into this. This parser is also a standalone library that can be used by other applications as well. If you receive notifications in a format that's already covered, you're fine. But since this is a standalone library that can be added onto, it's very easy then to add that additional parsing into this standalone library, which would then be incorporated into the circuit maintenance application as well. There's 21 SPs are already available with this, but it's very extensible and can be extended as well.
Gotcha. So does that show up as like an exception if I get a format that I know I'm supposed to be monitoring this email, something's happening, but I don't know what to do with it? That shows up as some kind of an exception that you can then build a new framework for, build a new parser for?
Absolutely, yeah. You don't have to build a new parser, but you just need to add to the existing parser to just a new format.
Gotcha. Okay.
Yeah. So yeah, it's very, very extensible, built to be very easy to maintain and improve over time.
Cool. Thank you.
You're welcome. So let's see, where was I? Okay, yeah, so what this parser does is it takes one of these formats that you might receive it in and then converts it to a standard format, a well-defined structured format that can be easily read by the automation to do what I'm about to show you in the demo in a few minutes here. So instead of this, where the service provider sends a maintenance notification, you have a network engineer, a highly skilled network engineer, by the way, doing manual data parsing, and then having to schedule the maintenance and maybe send an email to the group. And then, by the way, if that gets updated, I have to do that all again, times hundreds or thousands of circuits. It's almost unmanageable. It becomes crushing, and the people don't want to do this, nor should they have to. You should let the machines do this data parsing. So we do. We get this application gives you this workflow here, where the NSP sends a maintenance notification. The circuit maintenance application goes out, retrieves that notification, brings it back, parses, and then populates that data in Nautobot to give you a well-defined, easy-to-use maintenance object in Nautobot. We'll cover that. So once you have the maintenance data in Nautobot, that allows very easy on follow-on network automation to deal with the maintenance, like we talked about, automated alerts, alarm suppression, or automating the config updates before and then after the maintenance. So let's eliminate these manual tasks. Let your network engineers actually engineer. These are highly skilled, people, and they're being called upon to do this manual data parsing just because they happen to understand the technology. Let's let them do higher value tasks. Additionally, integrating your circuit maintenances in your source of truth really make sure that the state of the circuits and your interfaces is always up to date. And then again, this allows advanced follow-on automation to help deal with the maintenance and take a lot of that workload off of the network engineers. All right, we're going to get to a demo in a second here. I just want to cover what you're going to see in the demo. I'm going to show you retrieving an email with an initial maintenance notification. Then I'll show you the maintenance notification in Nautobot, and that will show the circuits being linked to the maintenance, and then the maintenance linked back to these circuits as well. And then I'm going to send an updated notification for that same maintenance, and we'll be able to see the updated maintenance notification in Autobot. So this is going to be the initial notification I'm going to send. This is the text. Now, this happens to be the NANOG best current operational practice format, which is a format developed by some folks at NANOG to help standardize maintenance notifications across vendors. So this is that format right now. But again, this could be HTML or CSV or something else tough to parse. But there's a few, and this is going to be the actual text sent in the notification. There's a few things I want to call out there. There is a date start timestamp, a date end timestamp up at the top, and then that larger red segment in the middle there, that is the specific circuit objects impacted by the maintenance, along with the impact for each circuit. Okay, we're going to go ahead and get to the demo. All right, so what you are looking at here is the Autobot user interface for those who haven't seen it before. There's a few things I want to just orient you to prior to doing the actual demo. So the circuit maintenance application can be accessed under the plugins menu. It's another name for application. And we'll go to notification sources. In this case, the notification source is an email inbox. And this account ID you see here, nbalerts@networktocode.com, that is the email address that your provider, your NSP, will send notifications to. So this is our inbox where we receive notifications. Specifically, we'll receive the notifications from NTT in this case. So you can have multiple carriers, different carriers sending to different inboxes on your side, okay? And if I click on NTT real quick here, this takes me to the carrier object. And under this custom field right here, there's my email address. I'm going to play the part of the carrier sending the maintenance. So what I've shown you so far is the inbox where you receive the notifications and the email that I'm sending the notifications from. So we expect that Tim Fiola will send notifications to the specific inbox. Okay. All right. So let's go back to plugins here, and we'll head to circuit maintenances and take a look what we've got scheduled so far. We have one maintenance on the docket so far. It occurred in the past and it got canceled. What I'm going to do now is I'm going to send the initial notification. So what I'm doing here is I'm sending it's an ICS file with some text in it that it's going to parse. So I'm going to go ahead and send that. And that is going to that mailbox that we talked about, that nbalerts@networktocode.com. So while that's happening, I'll go back to plugins. And let's go down to this icon right here. And this, John talked a little about this in a prior presentation today. This is a job that is provided to Autobot by the maintenance application. So this can be scheduled to run whenever you want it, really, on a recurring basis. I'm going to run this job once immediately. And this is going to go ahead and go out to the mailbox, find the notifications, and then parse these notifications and give us a maintenance object. So a few things just happened here really quick. So I just want to cover what happened. So it found the circuit maintenance we sent. It created the circuit maintenance object, and we'll explore this in a second. Then it's finding the circuits that are affected by the maintenance. Now, notice this here. We have 3 circuits that show impact. Then we also find 2 circuits where they sent us these circuit IDs thinking we own these circuits. We don't have a record of these circuits in our database. So we might be paying for this circuit and not using it or not know about it. So this flags that kind of information for accounts payable or network engineering to follow up on. Okay. So what I'm going to do now is I'm going to click on this maintenance object. Okay, this is the specific maintenance object updated 0 minutes ago, created by fetching that notification. And down here, there's a few things to note here. So let's just kind of go through it one at a time. The start time and end time of the maintenance, and just take a mental note. It's October 8th to October 9th. Okay. And then the specific circuits involved here. And then again, these extra circuits that they think we own that we don't know we own that we want to follow up on. So those are recorded as well. Okay. So let's go ahead and select one of these circuits here. And this is one of the cool things about having everything in a source of truth is you can make these relationships that might not be evident if the data is scattered everywhere. So what I did here is I clicked on one of the circuits that's part of this maintenance. And down here, there's a custom panel like John Anderson covered in a previous presentation that added by the circuit maintenance application. And it shows that this specific circuit is affected by two maintenances. One was the existing one that was canceled, but one is the one we just created. Okay? So again, from this circuit, looking at the circuit itself, I can see every maintenance that's scheduled against this circuit. And if I need more information on that, I can click on the maintenance, and it takes us back to our original object that we created. So we've come full circle. Okay? So again, now I'm going to show you what happens when when we receive an update for this maintenance from the provider. So we'll go back to our mailbox here, my mailbox, and I'll go ahead and send this updated notification right now. And back to Nautobot. So we'll go ahead up to our plugins again and run this specific job to grab the notifications from the mailbox. And we'll run this job again once immediately, but this can be scheduled to run daily, weekly, what have you. Okay. It's running. Things are happening. Okay. Okay, so, all right, it's done. A couple things happened here again. It's the updated maintenance notification was received. And then the next entry you see here is we updated the circuit maintenance in Nautobot. So we already knew the maintenance was there. Now we're updating it because we've received updated information on it. And if we click on our maintenance object again, the same maintenance object, note the same circuits are still here. Everything's the same except for the maintenance is now October 14th to October 15th. So it went ahead and updated that for us. Now, if you look at the 2 times I executed this, it took seconds with no effort by me. Imagine now if you get thousands of these notifications per year, it's handled for you. You don't have to dedicate thousands of hours to have a highly skilled network engineer doing these manual parsings and organizing. It's all right here in your source of truth. So that concludes the demo part of this. Are there any questions?
Real quick, sorry, this is Tyler Christensen. You said that you can schedule these jobs to run daily or weekly.
Yeah.
Is daily like the minimum? Sometimes we get notices for a circuit maintenance that happens in 8 hours because it's an emergency.
So here are the options on the screen. You should be able to see them. Once in the future, or recurring hourly, recurring daily, or recurring weekly. So you can get down to really granular notification periods.
Great, thanks.
You're welcome. Are there any other questions on the circuit maintenance application?
Sure, I've got one for you. This is Aaron Conaway.
Okay.
Can you go through the data that's used to actually correlate all this stuff together? Is it, provider, and then they have an ID and a date, or, I mean, how does, like for example, when you ran it again, how did it know that it was an updated notification?
Yeah, let me go ahead and share this slideshow again. Okay, so right underneath this date start timestamp here, you see a sequence, and this is specific to this format. Like there are multiple formats used by multiple providers. So the fact this supports 21 of the formats used by 21 of the providers huge value add, huge. But in this specific one, the sequence here, this is the initial notification I sent. The sequence is 1. The second notification I sent, the sequence was 2. So that's how you get the kind of the ordering of the maintenance updates.
Gotcha. All right. Yeah. Thank you very much.
Tim, this is Ed. Quick question on the actual display portion. Is there a way to actually tell what site impacts are gonna occur? So if it's gonna be a full outage, I noticed that you have all the related circuits, but I didn't know if it was actually stitching together like all the sites. Like if you have dependencies downstream, like your main hub site is losing its circuit, you're gonna have a lot of other sites that lose connectivity. For instance, if you're doing hub and spoke, is there anything that's actually stitching that together, or is it just, hey, you're gonna have an outage on this router and you're gonna lose this circuit?
Not at this time, but that's kind of like one of those follow-on maintenance automation operations you can do now. Now that you have this data in your source of truth, you can run another job, or you can extend this application to do exactly what you just said. Check for follow-on impacts. Go ahead.
So in this display, you can actually see which router interfaces are connected, right? You can actually see
so you would
circuit. You would pick the circuit, right?
Circuit, and then
you would actually see the devices on the right there. Yeah, for it's what Ethernet port is plugged into.
Yeah, and if you click on this trace button here, this shows you the full end-to-end what's going on.
You mentioned that you can have follow-on jobs to do things. Some folks like to put a circuit in a maintenance mode effectively before the maintenance starts. Are all of the things necessary to do that there, right? Because there's no event that's going to fire before the maintenance starts. So can you schedule a job to run at a specific time in the future based on what's happened with your notifications?
You know, the way I would envision that running is when you receive a initial notification and you have this data like we're talking about here, this maintenance object, I would imagine either an extension to this application or maybe just a different application jumping in there and saying, okay, now that we have this information per our, the way we do it here at, whoever we are, is we take the maintenance, we take the circuit offline 2 hours before the maintenance. That information is all very easy to get right here. So I would imagine that as being a follow-on job that would extend the capabilities as a follow-on automation action. The circuit, it doesn't do that specifically, but the beauty is all the data is right here, right now. So you can do that very easily because programmatically you can just retrieve this maintenance notification and all the details. So you can operationalize it a bit, really how you need to.